coming to you from Jezero crater on the surface of Mars. This is Mr. C.
8th graders, happy downhill day to you. I've got a guest who has popped in to be with you for a little bit. Good old Buzz Lightyear. Who doesn't like Buzz, you know what I mean? So, I'm a massive Buzz fan. He's so courageous and positive. And anyway, Buzz. So, be like Buzz. So, and you know his favorite expression? To infinity and beyond. You know, and we laugh at that. Wait a minute. How can you go beyond infinity? That's, not mathematically possible, Buzz. So, anyway, but what I like to think about that is, we believers are going to heaven. Kind of like infinity, forever. So it's kind of like infinity and beyond, kind of. Not exactly, but anyway, a little devotional for you from Buzz today. A little reminder that we're going to heaven forever if you've asked Jesus into your life to forgive your sins. So, wow, do we have an awesome future ahead of us. So, anyway, I wanted to show you that. Thanks, Buzz. I'm going to try to have a guest pop in each day. I've already got my guest picked out for tomorrow. So, no, I'm not giving you a hint. You'll just have to wait and see. I went through the metric system really quick in study guide number 1, which if you'll take out, we'll finish up today. I think we can finish up study guide number 1. But I wanted to show you, just really quick, a reminder of the metric system standard units, measurement words everybody knows and uses, for volume, 1 liter, about a quart in the English system, 1 gram for weight, about 1/4 a sheet of paper, and then for length, can I get it all in there? Yeah, I can. 1 meter, which is about a yard, a little more than a yard. 39 inches, isn't it? And change, yeah. About 39.5 inches. 1 meter, 1 M. So I wanted to review those. I thought, I probably should review those guys. So reminders, Friday a quiz. Here's what your quiz is on Friday. And this will be up by tomorrow evening in homework notes in RenWeb. 8th grade, homework notes, RenWeb, Wednesday evening, maybe earlier than that. But because I'm taping this on Tuesday, you wouldn't know unless you looked. So anyway, tomorrow, or I should say on Friday, your quiz is going to be on Newton's laws. So all 3 of them, plus his 4th law of universal gravity. So an object in motion, a baseball or whatever, will continue in motion in a straight line unless acted upon by a force, like a catcher's glove. Bam! The catcher's glove stops it, applies a force to the baseball. Force, push, or pull. An object at rest will remain at rest unless acted upon by a force that gets it moving. So Newton's first law. It's also known as the law of inertia. Inertia is the tendency of an object to resist changing. Its direction of travel, its velocity, just resistance to change. Inertia. And the second law is force equals mass times acceleration. So if the force goes, or I'll say it this way, if the mass goes up, the force goes up. The amount of force that an object has. It's got more mass, it's going to have more of a push. If it runs into something, for instance. If the acceleration goes up, it's going faster, and the force goes up, then it's really got a lot more force. F equals mass times acceleration. MA. F equals MA. And then The third law, for every action there is an equal and opposite reaction. For every action, equal, opposite reaction. There's Newton's 3 laws of motion. And then his fourth law, the universal law of gravitation. Every object in the universe attracts every other object. The closer they are and the more mass they have, the greater the attraction will be. Distance between the objects is a variable that affects their attraction and how much mass they have. More mass, more attraction. Closer, more attraction. I'll ask you those two on Friday. What are the two variables that affect the gravitational attraction between two objects? How close they are to each other and their masses. Okay, so I've covered all of those. I'm going to ask you about force. A force is a push or pull. And then I've got a couple of new terms for you. So you know force already. So there's a little formula. The amount of work that's done, W, is equal to the force applied to an object and the distance it travels. See that? F is force, D is distance. So the force, how much force is, the force equals the, I'll say it again, the amount of work that's done to an object, whatever it is, a baseball. Okay? The amount of work that's done to that baseball in physics equals the force that's applied to it times the distance it travels. So, and here's a problem. See this right here? So W equals the force, let's say a 5 kilogram force. That's 2.2 times 5. I think that's 11 pounds. So 11 pounds of force, or 5 kgs, 5 kilograms. That's the force. The distance the object travels is 6 meters. So you multiply those together. So 5 kilograms of force times 6 meters movement, 6 times 5, 30. And we call that Nm, Newton meters. See that? Nm, Newton meters. Now instead of Newton meters, we use joules. So the answer would be 30 joules. That's the amount of work that was done to that baseball. So work is done when an object moves in the same direction as the force that's applied to us. So if a baseball is thrown that direction, the amount of work that's done is equal to the force times the distance it travels, say 60 feet. Standard pitching mound in baseball. Anyway, no charge for that. So work is done when an object moves in the direction of the force that was applied to us. No move, no worky. Nope. In science, if no movement occurs, no work is done. Okay? Anyway, I'll review that tomorrow. And then eventually we're going to get power and energy. Perhaps tomorrow, but maybe not. SSRs, 10 SSRs due on Friday. And then your journals are due next week. Hey, has this got your attention yet? I'm going to look at how well you answered A 1 through 4, B 1 through 4, C 1 through 4, D 1 through 4. I'm going to give you a grade based on how well you did with that. And then your little drawings of the 8 microscope slides. And do they have a label? What are they? So, how's it going to look when I look at your journal? What if your journal doesn't come in? Well, you're already going to lose 25% if your journal isn't in on that Wednesday. So it's not an option. You've got to do it. So Mr. Phillip is encouraging it. And he and I are going to work together to give you some time. If you don't have much time at the end of a period, you can't say, well, Mr. Phillip and Mr. C didn't give us time. Then it's your job. You already were given a lot of time first semester. So it's your job then to come in advisory, lunchtime, working out of time with Mr. Phillip. So it's on you. So make it happen. Now, many of you I know of already, lighten up, Mr. C, lighten up. Well, the reason I'm being slightly, I'll say, aggressive, it's on you. The reason is I want you to succeed. I want you to do well. It's not bad, is it? Mr. Phillip and I both want you to be successful and get the highest grade you possibly can, winding up the fourth quarter and the second semester of your 8th grade year. So, get her done. Okay, you guys saw that TED Ed talk yesterday. So, hurry, Mr. C, or we're not going to have much time to work on the study guide. So, we'll see. It's all right. I'm not, as they say down in Australia, I'm not fussed about it. So, I'm not excited about it. No worries. So, no dramas, as they say in Australia. No drama. So, anyway, the TED Ed talk, 3 things that you can do to make your practice go properly, to have a proper practice, double P. 3 things. 1, no distractions. So turn off your phone. Turn off video games. Turn off your computer. So don't be hanging out with a friend probably, so you can concentrate on whatever it is you're learning. So the first tip is concentrate. No distractions. CD, concentrate. No D, no distractions. And the people who do that learn the quickest, improve the quickest. Their practice ends up really helping them faster. The second thing is to take breaks. Oh, great, Mr. C, I'll take a break like every minute. Oh, no, that's not what it means. Every 15 minutes maybe while you're studying, for instance, or shooting free throws, or 20 minutes if you're doing something you like physically. So have a break. The best at learning whatever the skill is they're attempting to learn will take consistent breaks. So no distractions, consistent breaks. The third thing is to visualize it in your mind. I remember years ago I was watching Winter Olympics, and I was watching these world-class slalom skiers. They were at the top. They'd taken the lift up to the top of the mountain, and they were waiting their turn to go down through the gates. Slalom, right? And here's what some of them were doing. So they weren't watching the other person go down. They were taking advantage of the time. Their eyes were closed, and they were doing this. They were imagining the different gates. They had memorized the gates they were going to go through and what their body was doing as they went through it. So how close the gates were to each other and so on. They were visualizing it in their mind. There was a study, as you know, in that TED Ed talk, that showed people who just visualized compared to those who were actually physically trying to learn something, they progressed as quickly as the people who were doing the physical activity. Now, once they learned how to do it, of course. So, the very first thing is no distractions, concentrate, and then breaks, consistent breaks. Just take a little breather, and then visualize it in your mind. Maybe even close your eyes. And then a fourth thing is to practice whatever it is you're practicing properly. Do it the right way. If you practice how to do something the wrong way, you'll learn how to do it. But it's not the proper way to do it. So you want to make sure you always find out what's the proper way to do this, whatever it is. What's the very best, exact way to do this? I watched a video last night of a professional piano player. She was giving a TED Talk, and she said that her piano trainer, teacher, mentor was very rigid in the way he wanted her to play the piano, to do exact things, to do it right. And she said because of it, she did it right, and it was in her head. It's why Monsieur Hajiak got French into my skull when I was at the University of North Dakota. Because he made us learn. He made us. He made us learn French properly. No distractions, take consistent breaks, visualize in your mind, and practice it the right way, properly. Okay? So, now, I've got a highlight. I've got 2 videos that I want to show you, and it may end up that you'll have a little time to work on science activities and those microscope activities. You know, on your own, would you do this? I just want to show you this. I didn't have time to get to the study guide. I will tomorrow. We'll finish this study guide tomorrow or Friday. Then Monday you'll get number 2, and probably next Wednesday number 3. So numbers 2 and 3 are just tests with the correct answers. So it's going to be a little easier. We can whip through the test pretty quickly. So again, I'm not fussed about it. But on your own, if you could look at the Fomin pillars of evolution: F, fossils; O, old age; A, accident; M, mutations; and N, natural selection, and the data for them. And then we'll go over this tomorrow. I'll make a point of it. So, but look it over on your own. Okay? Your homework tonight is to review Newton's laws and his law of gravitation, what a force is, a push or pull, what work is when an object moves in the direction of the force that was applied to us. Then work has been done. It involves movement. It's got to move. If it's just sitting there, in physics, in science, technically no work is done. No movement, no worky. Okay. And then how much work is done is dependent on the force applied to the object, F, times the distance it travels, D. And the answers are expressed in J. That's supposed to be a J. J for joule. So J for joule. Anyway, the video you're going to see now is a video by the, what does she call herself? The physics girl, Diana something, I can't remember her name. Anyway, she does a nice little job. You're going to watch a little video on work and force, and you'll see part of it today. And then I'm going to take you out to North Carolina, Charlotte, North Carolina, and you're going to ride on Fury 325. It's the second fastest roller coaster that you will have ridden on. This is number 7. Goes 95 miles an hour, and it's 325 feet high. That's why it's named Fury 325. So anyway, you're going to have a ride on it after the physics girl teaches you a little bit and reinforces what I already taught you about work and when work is done. You're only going to watch about 4 minutes of it, and then a minute and a half of Fury 325. So I will see you on Thursday. We'll review a bit more for the test and the study guide, and URRR on your own tonight. So, Mr. Phillip, if you'll do your magic, thank you.